I'm Anil Kumar. In this set of videos, we'll figure out how to find the angle when the angle is between 0 to 360 degrees and some trigonometric ratios are given to us. So I'll take a few examples and I hope that helps. We are going to round all the angles to nearest degree. The question here is tan theta plus 10 degrees is 1.5 and part B is tan theta equals to minus 0.5. The steps involved are kind of like this. Always figure out the quadrant in which the solution lies, right? That's the first thing. So here we are looking for a positive value of tan. We know all are positive in quadrant 1, sine is positive in quadrant 2, tan in 3 and cosine in 4. Now since tan is positive in 1 and 4, we are looking for a solution which could be along this principal angle. Is it okay? Where let us say the angle is alpha, the acute angle, related acute angle. Okay, so always find related acute angle and then the principal angle as the final solution. So what I'm trying to say here is we are given tan theta plus 10 degrees is equal to 1.5. We'll first find alpha, so we can rewrite this as tan alpha equals to 1.5 and find alpha as tan inverse of 1.5. I hope you get the idea, right? Set your calculator to degrees. Inverse tan of 1.5 is equal to 56.3. Now we have to round this to nearest degree, so we could round this to 56 degrees, correct? All angles are in degrees. So we know angle alpha, which is also one of the solutions. The other solution, however, is this one. Is that okay? Which we can get, so we can say theta is equals to 56 degrees, which is in quadrant 1. The other angle theta will be 180 degrees plus 56 degrees. Is it okay? So let's add them up and write down our answer. So we have 180 plus 56 as equal to 236. So we get 236 as the other answer. So we get two answers. Now let's look into the next part. At this stage, actually, you can always pause the video, answer since you know the technique, and write down your solution. Now we are looking for a negative value. That means we are in quadrant 2 or in quadrant 4, right? Since you know that tan is positive in quadrant 1 and 4. So we're looking for a solution like this somewhere, right? Okay. So what are we going to do here? We'll consider acute angle alpha just as we did last time, and we'll figure out what alpha is. So first I'll change my question, write tan alpha as 0.75. Note that I'm taking positive value, right? I'm not giving you the value of theta as the answer. I'm finding related acute angle alpha. So what is alpha equals to? Alpha will be tan inverse of 0.75. Let's use the calculator. Find inverse of tan 0.75. That gives us 36.8, which can be rounded to 37 degrees, correct? Now since alpha is 37 degrees, what are the two answers? Well, one of the answers is right here. This is alpha, right? That is also alpha. So the answer here will be theta, the principal angle, is equal to 180 degrees minus 37 degrees. That is one solution. The other one is 360 degrees minus 37 degrees. Since we are interested in negative value of 0.75, correct? So let's figure this out. So it is 180 minus 37, which gives us 143 degrees. The other one is 360 minus 37, that gives us 323 degrees. So these are the two solutions. So I hope you get it, correct? Even otherwise, you should remember that time period for tan is 180 degrees. So if you find one, by adding 180 degrees, you can get the other one. So 143, you'll notice that 143 plus 180 will result into 323. Do you see that? Here also you will notice that 56 plus 180 will result into 236 degrees, simply because tan theta has a period of pi or 180 degrees. Do you get my point? Okay. So we'll do a few more questions, and I hope that will help you to always find out correctly the value of theta to the nearest degree. Well, I did a mistake here. It was theta plus 10. So this answer is not theta, it is theta plus 10. Let me rewrite here. And therefore, what is theta equals to? Let me correct it. I just saw it in the last minute. Sorry for this. So that implies that theta should be equal to 56 degrees minus 10 or 46 degrees. And in this case, theta will be equals to 236 degrees minus 10, which is 226 degrees, correct? So our correct solution will be, let me write down here for part A, that theta is equals to 46 degrees and 226 degrees. Is it okay? Because the question was theta plus 10. I kind of forgot. Okay, anyway, but this part is okay. Perfect. So good, I saw it. Feel free to write your comments and share your views. Let's move on and see the next question now. Thank you. We are given angle theta, where theta is between 0 degrees to 360 degrees. Solve for theta to the nearest degree. First equation is sine theta is equals to minus 0.6350. And the second one is half of cosine theta is 0.2532. Now we'll use the calculator to find these answers, and we'll round them to the nearest degree as asked for. Let us try to understand the situation. The first one here is that sine theta is a negative value, correct? That really means what? If you apply the rule, all are positive in quadrant 1, sine is positive in quadrant 2, tan in 3, and cosine in 4, that really means that we are looking for two solutions for negative value of sine theta, correct? That is to say, we are in quadrant 3 or in quadrant 4. Perfect. So first step is to decide what are possible angles. So the possible angles are in quadrant 3 or 4. That's first thing. Now actually what we do here is that we always find a related acute angle first and then the principal angle theta, since we are getting two answers. So let us say alpha is our related angle. So I'll rewrite this question as sine alpha equals to, here all are positive, so I'll write this as 0.6350. So what is alpha equals to? Alpha is sine inverse of 0.6350. Perfect. So we can now use the calculator, which should be set in degrees. And we can do shift sine inverse, which is 0.6350 equals to, we get the angle as 39.41. So let's write this as 39.4. Since we want to write answer to nearest degree, let me write this itself in nearest degree as 39 degrees. Does make sense to you? Okay. Now, that really means that the acute angle is 39 degrees. What is theta equals to? Now in this case, theta has two answers. One, theta is equals to 180 degrees plus 39 degrees. And the other is theta equals to 360 degrees minus 39 degrees, correct? Since one of the angles which we are looking at is the smaller angle, this, in quadrant 3, and the other is the bigger angle in quadrant 4. Perfect. So let's do that. So what we get here is 180 plus 39, which results into 219 degrees. The other one is 360 minus 39, which results into 321. So those are the two answers. Perfect. Now let us see how to solve the next question. Here we are given half of cosine theta is some angle, correct? So what is cos theta equals to? Right? So in this particular case, we have to find that there's a typing error here. It should not be degrees here. We're talking about angle in degrees, correct? So what we are given here is half of cosine theta is some value. Is that okay? So that means what is cos theta equals to? Cos theta is 2 times this value, which is 0.2532. So let's figure out how much it is. So it is 2 times 0.2532. That gives us, in decimals, 0.5064, correct? So cos theta is basically equal to 0.5064. Now, we'll apply the same strategy as we did in the first case. We're looking for positive value of cosine. That really means that either we have solution in quadrant 1 or in quadrant 4. Perfect. And we're looking for the acute angle alpha first. Is it okay? So what is alpha equals to? Alpha will be cos inverse of this value, which is 0.5064. Correct? So let's find inverse of this value. So shift cos inverse of our answer is equal to, we get an angle which is 59.57. Rounded to whole numbers, we get 60 degrees. Is it okay? So that is alpha. So what is theta equals to? Theta is equals to alpha, quadrant 1, which is 59.5, 60 degrees. Or theta is equals to 360 minus 60 degrees. Is it okay? That is 300 degrees. So we have two answers for the second part also. The answers being 60 degrees and 300 degrees. Correct? So I hope you understand that whenever we are interested in finding the angle, given the value of the trigonometric ratio, we have to first figure out in which quadrant we are. So in the first case, sine negative means solution in quadrant 3 and 4. Cos positive means solution in quadrant 1 and 4. So in either case, you first find the related acute angle. Once you find the related acute angle, then you get both your answers and write them down. So I hope this strategy will always help you to find the right solution. Feel free to write your suggestions and comments. If you subscribe and like my videos, that'd be great. Thank you and all the best. Now here is a test question for you. We have already done angles related with sine, cosine and tan. The question for you is, given angle theta, where theta is between 0 to 360 degrees, solve for theta to the nearest degree. Part A. Sine theta plus 20 degrees is equal to 0.6240, and part B is sine 2 theta equals to 0.75. So those are the values given. You can always pause the video, answer the question, and then look into my suggestions. Now let me take up part 1 first. What we are given here is that sine is positive. Sine positive means we are working in quadrant 1 or in quadrant 2, correct? You remember the rule? All are positive in quadrant 1, sine in 2, tan in 3 and cosine in 4. Perfect. So we'll begin by answering what the related angle alpha can be. Is it okay? So we'll replace this question by sine alpha equals to whatever is given to us, positive value, 0.6240, alpha will be equals to sine inverse of this value 0.6240. So let's figure this out. So we have shift sine inverse of 0.6240, which is equal to 38.6. 38.6, rounding to whole number, we get 39 degrees. So alpha is 39 degrees. Perfect. Since we know alpha, we can now find both the possible solution. One of the solution is alpha itself. The other one is 180 minus alpha, since that is also alpha, correct? And the angle of interest is theta plus 20 degrees, correct? So we have two possible scenarios. Theta plus 20 degrees is equal to 1, if I in quadrant 1, 39 degrees. The other one is theta plus 20 degrees is equal to 180 minus 39, right? 180 minus 39 degrees. Perfect. Now here we get theta as equals to 39 minus 20 degrees, which is 19 degrees. Perfect. And on the other side, we get the value of theta as equal to, let us calculate. 180 minus 39 is equals to 141. Bringing 20 there, we get 141 minus 20 degrees, which is 141 minus 20 is equal to 121. So we have two answers for theta, and our answers are theta equals to 19 degrees and 121 degrees. Perfect. Now let's just do the next part. Now here we have to understand one more thing, which is we are given that theta is between 0 and 360 degrees, correct? So what should 2 theta be? It should be between 0 and 720 degrees. That is a huge difference. Is it okay? But the strategy is kind of similar. We'll treat this question first as, let's say, sine alpha equals to 0.75. Knowing fully well we are looking for a positive value, that means we are, as in this case, looking for two solutions, one in quadrant 1, the other one in quadrant 2. Perfect. Now that gives us alpha equals to sine inverse of 0.75. So let's find this angle. So we have shift sine inverse 0.75 equals to 48.59, approximating to 49 degrees. Okay. So we found one angle. Now what should be the other angle? We'll call these angles as phi, or we can say what is 2 theta equals to. So we have 2 theta equal to 49 degrees, right? Which is same as alpha. And also 2 theta could be 180 minus 49, correct? So the other angle is 180 degrees minus 49 degrees, which is equal to, let's do it, 180 minus 49 equals to 131. So the other angle is 131 degrees. Okay. Now, since we are talking about 2 theta, not just theta, we have to go one more circle. That is to say, add 360 to both. So let's add 360 to 49. So we get 360 plus 49, which is equals to 409, and 131 plus 360. And that gives us 491 degrees, correct? So these are also solutions. Since 2 theta means you have to go one more round. Do you see that? Okay. Now what is theta? To find the value of theta, we have to just divide them by 2. So we have 49 degrees over 2, 131 degrees over 2, 409 over 2 degrees, and 491 over 2. Perfect? Okay. So these possible answers are, so 49 divided by 2 equals to, in decimals, 24.5, we'll round later. Then we have 131 divided by 2 equals to, in decimals, 65.5 degrees. And then we have 409 divided by 2, which is, in decimals, 204.5 degrees. And we have 491 divided by 2, which is equal to, in decimals, 245.5 degrees. Since we have to round them to whole numbers, we'll round them to 25 degrees, 66 degrees, 205 degrees, and 246 degrees. Perfect. So that becomes our solution. Now, some of the students who are in senior classes might have learned that when we have 0.5 to round, then we normally round to even numbers. Is that okay? Even numbers. So they might get the answers as this one as 24 degrees, 66 degrees, 204 degrees, and 246 degrees. Okay, so both are correct. It depends what strategy you are using. Most students just round higher if you have 5 or more. Perfect. So we'll, for the time being, go with the first set of solutions. Is it okay? So that is the solution for us in the given scenario. However, if you learn something else about rounding, you can apply that and write down the correct answer. I hope that helps. Thanks for watching and all the best.